forgot to start recording. But anyways, so that means that 3 times 3 is going to give us the area of a square, right? So whenever we are squaring something, we're pretty much finding the area of a square with those sides, right? So 3 squared tells us that 3 times 3 means we have a square with an area of 9. And so that's why we call it squared, right? 3 squared. Okay? And I mean, it works the same when we're talking about cube, when we're talking about 3 cubed, which is 3 to the 3rd power. That's finding the volume, not the area, but the volume of a cube, right? But we're not going to get into that. You know, that's for later. Okay? But anyways, so that's why we call it a square, right? That's why we call it 3 squared, because we are actually creating a square with an area of whatever it is, right? But then if we have 9, how do we go back to its original form, which is 3?
Square root.
A square root, right?
So, I was going to say divide.
So when we do a square root, we're literally finding the root of the square, right?
Wow.
Okay, so if we were to take the area and take the square root of that, the root of that is 3, right? So we're going back to 3. Just like any other operation, right? If you do adding, you can undo it by subtracting. If you do multiplication, you can undo it by dividing. If you square something, then you can undo it by taking the square root, okay? So it's just like any other operation, it's finding the opposite or undoing what you did previously. And when we're actually solving equations, let's say we have 10 squared, right? Equals, I don't know, let's say 10 squared is equal to x. Or sorry, not like that. Let me see. Better yet, how about x squared is equal to 100, okay? So to solve this equation, remember we need to do the opposite operation, right? So since we're squaring, how would we find x in this situation?
Look at a multiplication chart.
Well, remember, we just went over it, right? What is the opposite of squaring?
Square root.
A square root. So if we take the square root of both sides, that cancels out, and x is equal to the square root of 100, which is what?
10.
10.
10.
See that?
Stop.
So that's how we use our square roots, okay? So we need to make sure that, you know, we have our perfect squares in mind, right? So what are our perfect squares?
Like numbers, you're saying?
Yeah, right. What are our perfect squares?
Like
4.
2, 4, 6.
No, not 6.
I don't know.
It's like a number.
Like our prime
15?
numbers or something?
Not prime numbers, but let's.
Is it 16 there?
Yeah.
64.
49. Yeah, 64.
What about 36, sir?
36 is there.
Oh, 81.
Right. So remember, these are our perfect squares, right? So if we take the square root of 1, that's 1, right? We take the square root of 4, that's 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5, 6, 7, 8, and so on, right? We need to make sure that we keep those in mind, right? And the opposite way, right? If we do 1 squared, then that gives us 1. 2 squared is 4. 3 squared is 9. 4 squared is 16, and so on, right? Okay, so we need to make sure that we are doing well with our well, we have in mind our perfect squares. Let me write the rest of them. At least to like 12, Yeah, so 81, which is 9. Square root of 100, which is 10.
And
121, which is 11. And 144. Okay. So we need to make sure that we have our perfect squares in mind, because then when we come to an imperfect square, we need to make sure we know how to simplify, right? And we did this a lot last year when we were doing triangles and Pythagorean theorem and stuff like that, right? And distance formula. We did this last year. So do we have those down?
Yeah.
Yeah? Can I take them off?
I screenshot it.
Huh? Okay.
I screenshot it.
So what is an imperfect square?
A circle. I'm
No,
just
no
kidding.
circle.
I'm just kidding.
A triangle?
I'm just joking.
No, we're just talking about an imperfect square, right?
Oh.
would it be 6?
I don't know.
So an imperfect square is a number that when you take the square root, it's going to give you a decimal, right?
Like 6, sir?
Right. 6 would be an imperfect square as well. We take the square root of 6, that would give us, I don't know, like 2 point something maybe? I don't know. Yeah, it's like 2.4. Square root of 18, that gives us 4.2, 4, and a bunch of decimals. I don't know. But basically, imperfect squares are kind of, you know, we don't really like that because I don't like dealing with decimals, you know. When we get into higher math, it's already hard enough, and then putting decimals in there just makes it like that much harder, and we don't really want that, right? So what we want to do is simplify the square root, right? When it's an imperfect square, we're going to simplify the square root. Do you guys remember how to do this?
Yes, sir.
Kinda.
So we want to make sure that we find two factors, right? One of them is a perfect square and the other one is not, right? So what is two factors here that could give us a
2 and
perfect
9?
square?
2 and 9.
2 and 9.
2 and 9, that's right. So all we did was just split it into two different square roots, right? That is still the same thing as saying 9 times 2, which is 18, right? But this time we can take the square root of 3, right? I mean, sorry, the square root of 9, which is what?
Which is 3 of them, sorry.
No,
Oh,
the
wait,
square
what?
root, the square root of 9.
3.
Yeah.
Oh, it's 3.
No,
And then we leave our square root of 2 there, and that's our simplified version, right? 3 square root of 2.
yes.
Okay? So what about the square root of 75? How can we simplify that one?
3 and 25?
3 and 25. Remember that whenever it ends in 5, you know, a pretty big clue is that, or it's a pretty big clue is that it's going to be maybe 25, right? So we can split this into square root of 25 and 3. So if we simplify this, what would it look like?
5 square root of 3.
5 square root of 3. Pretty good. Okay. What about the square root of 98?
Hold on. Nine? Is it 9 though? Is it 10? No, it's not 10.
No, because 98 divided by 9 is a decimal, so we can't do that.
Ah. I did something wrong. Hold on.
So if we're not entirely sure, try your perfect squares one by one, right? So let's say 98 divided by 16. That doesn't work. 98 divided by 25. Of course, that doesn't work.
Would it be 8? Wait,
98
4.
well, 98 divided by 36 doesn't work either. But what about 98 divided by 49? So actually, 49 and 2, right? 49 times 2 gives us 98. So then to simplify this, what would we end up with?
7.
7 square root of 2.
2.
There we go. So if you're not entirely sure, just start dividing the number by all your perfect squares and see which one fits, okay? So 98, I ended up coming up with 49, and I found out that you can divide 98 by 2, and it'll give you 49, right? So that is how we simplify our square root.
Guys, be quiet.
Okay, last example. Say we have a fraction, and we take the square root of the fraction. This is really the same thing as saying the square root of 36 over the square root of 25. So even though it's a fraction, we still apply the square root to both the numerator and the denominator. So what would be the answer in this case?
6 over 5.
6 over 5, yes. Okay, so whenever we have a fraction, we can apply it to both the numerator and the denominator. Now, there are times, for example, let's say that, let me
Sorry, sir, my Wi-Fi cut.
That's okay. So let me see if I can come up with a good example here.
That song's about marshmallow.
All right. Well, that's fine.
To that.
Okay, so let me see what I got. Okay, so today's work is going to be on Delta Math as well, okay? And
It's gonna be the stuff that we just went over?
Yeah, so practicing simplifying the square roots, okay?
Okay.
So we wanna make sure that, I think at the beginning, the first part of the homework is making sure that we practice our square root, our perfect squares, right? So it will give you square root of 36 and you say that it's 6, right? Square root of 49 is 7 and so on, right? So it's gonna be, that's the first part of the homework. The second part is making sure we are simplifying, okay?
Yes, sir.
So that is on Delta Math. And again, make sure that you do that, which is due on Friday. And if you're missing any other work, don't want to call
Are
you
we
out.
missing any other work?
Well, don't want to call you out, but David, my guy, what's going on there?
David was on this whole thing?
Yeah, he's
Yeah,
I wasn't
I'm
even
here.
paying attention.
he's literally always doing something somewhere.
David, buy me a shirt.
bro, I'm in Zoomies
For
right
real,
now. Bro.
same.
I'm in Zoomies right now, G.
I'm not playing. Remember, we said we'd get each other something for our late birthdays.
All right.
This one, yeah. Ooh, I'm gonna look at.
Okay.
Oh my gosh. Be